Hello and welcome. I'm Tessa Hayman and I'm a product specialist at Aimson, which means that I am a technical specialist and also do some outreach and do presentations like this. And we're going to talk about the NEVFMA project, which is yet another real-time modelling project that was done in Oxford this time. So what does NEVFMA stand for? It stands for Network Emissions Vehicle Flow Management Adjustment. The project was building a real-time model of Oxfordshire County, which then combined with EarthSense's Zephyr model and gives real-time air quality data from our traffic model. And we then use that air quality data as well as our traffic outputs on congestion to identify where there might be problems and then come up with some solutions in real time which can be tested. We also had Siemens on the project. They were doing some stuff with AI and signals, but we're not going to talk about that in this presentation. And we also had Oxfordshire. Our objective in doing this was to try and mitigate the air quality problems across Oxfordshire and the road transport. And what we wanted to do was see if a real-time model could both improve congestion and maybe the air quality problems around that. And in doing that, we wanted to look at using existing council infrastructure to build this and try and aim to reduce the tailpipe emissions. So Aimson Live, which is our product, is a real-time traffic model which can predict near future traffic conditions. So it can give predictions in 50 minutes, 30 minutes, 60 minutes time. And in real time, it can also test and compare response plans. So if you give it a set of response plans, it can check and give you KPIs, not just on traffic, but also on that air quality. So we have that real-time emissions model predicting the near future air quality, but it will also test with those response plans what the air quality might be like with those different response plans. To enable this, we have three different parts of the product: monitor, predict, decision support. To monitor the network, you have your real-time traffic model, which is 24/7 of the whole of the Oxfordshire County. And that means that you can look to see if something is happening. Is there some congestion? Are things different to normal? To try and then predict, we have traffic patterns and profiles. So we can give predictions of analytic and simulation-based predictions. They use the historic and real-time data to come up with this. So it uses some clustering to try and predict what will happen based on what we think is currently happening and what has happened in the past when this has happened in the future. If you then notice that either there is a problem now when you're monitoring it, or there might be a problem in the near future, you can then use our decision support. So we can give out those tailpipe emissions and give out some KPIs which the user gives us and to tell us what they are care about. To build the NEVFMA product, we had a 24/7 model that was based on 2019-20 data with 10 different profile types. That's different kind of traffic patterns, not different vehicle types. You then have the ITS system. So we had a load of real-time detectors, which are all feeding into our model. And then we've got the air quality estimates as well for CO2 and NOx coming from EarthSense. And all of that comes together to give our real-time decision support system. You have the KPI outputs, just really easy for a user to see. These are all in an online system. And you also have map-based outputs and zonal outputs, as well as the air quality. Now, I am going to be another person who talks about COVID-19. There is a nice different graph. It is something that came out of this project, is that in real time, we could also see what was happening in Oxfordshire with the traffic. So as far as I know, I think that some of this was used in Oxfordshire to try and help their traffic planning as well as their understanding of the pandemic. And what we saw was some slightly aside piece of information, but we could actually see the political changes that were happening. And we saw the traffic reflecting those political changes as well as different day types. So in the spring bank holidays, suddenly there were more traffic and then it might come back down. And that, I think, is again, slight aside, that this could be used for getting more in understanding of different reasons for travel. You can start to isolate leisure from essential traffic. So even if it's worse, 30% of traffic was essential during the pandemic, and you just can't get rid of it. And you might say that the remaining 10% are those working from home, and the people that we generally think, oh, the commute are people going to office. But if only 10% of the people who are working from home, perhaps our traffic management needs to change. Anyway, slight aside. Other things that we noticed were that every single day was different, even during the pandemic. That things are fluctuating and not in a completely predictable way. It's not like every Monday is the same Monday. So the way that we work it out is we don't have a normal Monday. Instead, what we do is we analyze the historic data first, and then we identify the common patterns. It might be the case that pattern 1 or pattern 8 is a normal Monday, but it might be a normal Tuesday. We don't really know. But then what we do in real time is we identify what the current pattern is, and we then provide analytical and simulated predictions based on that. And that current data then becomes historic to improve those patterns over time to get more of an understanding of what's happening. You can also then build an alert system that then says, okay, what's happening now is not what's usually happening on this pattern or usually on a Monday, and those alerts can be sent out. And then this slide has already been covered previously, the wonders of real-time simulation. But there are some other additional advantages. One is you can get a wider coverage. So usually you can only get coverage where your detectors are. But if you start to build simulation in, you might be able to give predictions of where there aren't any detectors. You can also start to look at non-recurrent events and identify non-recurrent events. And thirdly, it starts to allow you to emulate signals. So one of our strengths in AIMS Live is we do have some links to some emulators, such as Scoots and SCATSIM, which means that we can emulate some real-time signals as long as the emulator is speedy enough. So as long as that's done, we can then start to put that in. And then that allows you to test response plans in real time and make sure they are put out. So I'm just going to go through some case studies. And we were talking about some roadworks, and luckily I have a roadworks case study. So one of our ideas for this kind of use case is not just in real time unplanned things, but you might have planned works. So for instance, the A423 Kennington Bridge, that is at the south of Oxford on the Ring Road, and it is planned to be closed in, I think it was 2023, or maybe 2022. And it requires full closure to try and replace it. So we thought about, okay, what could you do? If you do nothing, then within 60 minutes of this happening, you'll get severe congestion across the south of Oxford. We tested invoking a traffic management plan, which is just a simple contraflow system, and we saw that the effects were mitigated, although you do have some density increases across the network. And this is important because with that air quality, you can see that over the hour, this spreads into the residential areas, which is where the effects of nitrous oxides are most apparent. And this is on a planned work, so you can do this offline in normal traffic plan, but the ones that's doing it in our real-time system is that you can not just do it on a typical day, you can then start to test the effect on lots of different traffic patterns to make sure your plan works over everything that you think it might. And then test the effect of traffic management on route choice. You can also test the air quality, which you might not get. And obviously air quality is much less predictable than traffic because the effects of wind and canyoning is just immense. So what we can see is that by doing it in a real-time system, you can then take what is happening right now and check that your response plans or set of response plans is right for that day. So you might have a planned work, but you might want to, before you put in the traffic management, check that you have the correct response plan for that work. And then perhaps that bridge might need to be have some emergency works on it. You can then rapidly test different response plans in that case. The other case study we're going to look at is improving AQMAs, which is air quality management areas. So we're going to look at Botley Road, which for those of you who know Oxford is one of the major thoroughfares into Oxford. It has a park and ride and is the entry to the station, and it's well known for having lots of congestion and has had historic problems with nitrous oxides. So what we did is we had a look at this road, and we found that the modelled nitrous oxide exceeded legal thresholds on 57% of the evaluated days. We then put in some response plans, which we designed and aimed to the next, and those reduced modelled nitrous oxides by 60%, on 60% of the days evaluated, and an average improvement of 5% was seen. And those were just with some relatively simple response plans. More bespoke response plans could be created by those in the know. And then what we saw was that actually in our second evaluation period, as the traffic returned to more normal levels, that the improvement from these response plans was much greater, and that the maximum benefit doubled from 20 to 40%. So in summary, as I think we've all heard enough today, typical days aren't necessarily typical. Our system learns and adjusts the longer it is deployed. So instead of having one day and just relying on that, we can start to learn and see how things adapt and make our predictions better as we deploy it longer and use those artificial intelligence systems as well as simulation to do that. We also can see that real-time systems can aid in traffic management for both planned and unplanned events. And there are lots of new things that we can add in there, and we hope to get some more partnerships and projects out there. So finally, I want to thank you, Innovate UK and Highways England, which are now National Highways, help fund this project, and Oxfordshire County Council, who happily let us use their roads and data to test on. Yes.
Right. Courtesy of the projector mishap, we're just going to fiddle with the running order a little bit. So the next item was pre-recorded because our colleague from the department couldn't be here. So the suggestion is that we will put that on the website so people will be able to kind of enjoy that just as much as they would have done sitting here. So that has created a bit of a buffer. So we now have a few minutes for questions.
Lots of questions.
Unless you want me to just move on. You know, but does anybody have any questions of Tessa? Yes.
So that's very interesting and is very similar to some of the situation. Just wondering, in terms of the use cases, obviously the examples are very much around the day-to-day traffic management. But as the data and evidence that you gain from that being used in any business cases going into the FT or government joint diagnostics, we've been proposing several approaches. And Jack, who basically picked it back and saying, you haven't got any evidence that
Yeah.
Well, let us try it. Idea. They've been very snippy about that approach, very snippy about certain design technology. You've got to sense what is an app.
Yeah.
And so providing us data. Jaku don't accept. So it's Jaku on your usual tunes and takes any 6 to 1 so to get the data after. So it's kind of just wondering if you've had that sort of dialogue with sort of DFT.
So I don't think we have personally. So I'll come back to this side. It is quite early days in the project, so it's relatively, it's definitely not a year's of fusion tubes. But I'm going to be horrible and just ask Ruth, potentially, as she is the one that got all of our data.
Yeah, I'm sorry, I didn't really hear the
Oh, sorry, I should have
question
repeated the
properly.
question. The question was, has any of this been used to present potential cases to DFT and JACU to improve the air quality, as in Coventry they already have some Zephyr detectors and they've had some issues with that?
No, one of the things that we've been working with Sentinel is about the need for type approval for real-time air quality sensors. We're also working with Birmingham University in their public health teams. So this hasn't been the only air quality project that we've been running in this box area. And also, if you look up transition air quality, UK, lots of air quality information in about different types. So what Birmingham University are trying to do at the moment is evaluate real-time air quality sensors, sort of like from the really cheap ones to sort of like the expensive ones, to actually so that they can go forward to type approval in the future. So being able to do that comparison between sort of like fusion tube data and the real time. And yes, we have locations where we've got co-located diffusion tubes and real time to sort of like be able to undertake that work. And really, it's sort of like working with our public health teams is really important about where we sort of like move forward in air quality. Air quality isn't actually a county responsibility; it's a district responsibility. So again, we're having to work closely with our district colleagues on this. And one of the things that we had to get out of in the future from this is that we'll actually be able to advise up the residents of Oxford about when they might actually want to go out and do exercise, particularly if they're, say, recovering from a heart attack. So they're being told by the doctor they've got to go out and do exercise. But if they're doing that exercise when the air quality is really poor, that's not the best time to do it. So it's about joining everything up, and this is why you need data, and not start doing it. It's just transport about actually got to use data sets across the whole of the authority.
I'm going to leap in at this point.
Oh.
Run out of time, so I can't ask you any more questions, so you're spared.